Okay, this is a really pretty big patch that I've got loaded up. This is on the course page already. It's to show you the difference between three different types of automation using no transitions, using line for linear transitions, and using curve for exponential transitions. What I've got is good old Anton.wave, and it's loaded up into a flanger. Good times. Now, the way that this patch is set up, it's a little bit on the complicated side, but what's going on is I've got different transitions going on here. I have no transition, in which case, once I turn this metro on, it will randomly jump to different values. All those different values are going to happen. It's going to be really crazy. You're going to hear them every couple of seconds changing. There is transitions using line, which will use the line object to create linear transitions for every one of these faders. The way that is working is if you open up line, you can see that I've got $1, 2000, $1, 2333, $1, 2500. That is, if you take a look at the list, you effectively are replacing this. So you ramp to value in time. So in this case, it is ramping to the value of whatever it randomly receives from this metro in 2000 milliseconds. Then, last but not least, you have curve. Curve is an audio rate only object. So line exists as both a control rate object and as an audio rate object, where it would be line with a tilde. Curve only exists as the audio rate object. The arguments are the same. You give it a message with $1 and a time, and it will ramp to that value at that time. But curve is going to work as an exponential ramp generator. So let's take a look at that real quick. If I go from 0 to 1 in 500 milliseconds, and then 1 to 0 in 500, or the S curve, you get these exponential curves. It's very, very different between curve and line. So we take a look at the two of them. Yeah, you see, curve just has that exponential curve to it, which is really important because that is how the ear is attuned to hear things. Frequency is exponential, doubling decibels is exponential, all of that. So it can be very, very useful to have that as something in your back pocket, but we do have to translate it. So curve has to go into snapshot. Snapshot, when it's running, which is what this one message tells it to do, is going to set it to randomly go, or not randomly, to fire off every 10 milliseconds. So every 10 milliseconds, it's pulling this input from curve, this audio signal, and it's converting that into a number. Then when it receives 0, snapshot stops working. And this is not easy to see, but there are all of these are hooked up as well. It's just kind of behind this one for the one. But those are all going to every snapshot. So every 10 milliseconds, when snapshot is turned on by selecting curve from the transition menu, it will send, first it will send the 1, turns on all the snapshots, and then every 10 milliseconds, snapshot pulls the value coming from curve. One thing to keep in mind with both line and curve is that if you take a look at their arguments, they both have a grain. They have an initial value for their first argument, and then they have the grain size. That grain is effectively the polling interval built into the object, so how fast it will outlet its values. So those are both set to 10, and the snapshot is set to 10. Obviously, if you don't need it to be at that fine of a grain, you can set snapshot to a larger interval. And doing that can get some really interesting things if you want to have this effectively running as a sample and hold, but you're doing it that way. So let's hear a difference between the transitions. I'm going to set it to none. I'm going to turn on the random automated parameters and then hit play on Anton. So it's randomly jumping, and that can be kind of cool, but there's no smoothing factor. So if we're not careful, we'll get pops. It might send the dry wet to randomly go from 0 to full on at 1, and that would not be cool. Let's run it through line instead. So line will be creating linear ramps. Again, it takes the value coming out of random. That gets pocked with the index number of the U menu, and then that's routed based on the index of the U menu. So currently it's receiving 1 because it's coming from position number 2 in the U menu, which is the line. It's getting the value, so that's 1 and 57. So it's coming out of this first one. But let's turn that on, and you can see what happens when that is using a linear ramp. So everything is considerably smoother, with the exception of time, and the reason for that is that this is a float, this is a float, these guys are floats, but time, if you take a look at the style, is set to type integer. And the reason for that is that I kind of just left it like that by default. I like to think of time as just whole milliseconds and not fractions of them. But you can change that to a float and your mileage may vary. Let's take a look at curve, and this is going to be some pretty dramatic changes. Back to none. Now you notice that curve is moving so fast that it's kind of hard to see at times. Again, these are exponential ramps, and if you have really, really big values, that will work fine, but if you have really small values, like say 0 to 1, not so much. So what's happening with that is that, yeah, it's ramping up, but it's ramping up really fast. You'll also notice one thing when I change between curve and line, some of those values are still being processed. It's just still in there, kind of stuck effectively. So that's something to really be aware of with the transitions, is that if you have stuck values, and you very well might, you need to kind of flush them out and wait for them to go through. Turn it back on, and it should, there we go, work. But that's just a couple of the different value types that you can use to create ramps. So there's line, there is line with a tilde, which is going to operate at the audio level, and then there is curve. Again, with snapshot, if you change the value of snapshot when you've got curve set, you'll notice some really interesting things. So let's try snapshot, and I'm going to set a value of 200. You can actually hear it changing because it's jumping effectively. If I take this down to 5, I'm just going to paste it in across all of them. We still got the exponential movement, but it's much smoother. And then if I take it to some ridiculous extreme, like let's take it out to 250, or let's try 1,000. How about that? This is going to get really funky really quick. At this point, I might not actually be getting the values that I'm supposed to be getting. So the value coming into curve is 48, and it's coming to 0.48. That's correct. But keep in mind, my polling interval is every 1,000 milliseconds, but my metro values are changing every 3.3 milliseconds. So this can get some really interesting effects where you're approaching your final value, but not doing it exactly. And again, your mileage may vary. It's a good trick to have in your wheelhouse, though. But for now, just take it back to 10. One thing to keep in mind with Snapshot, though, is that using lots of snapshots to translate and intercept the audio signals into data is that it does get a little CPU intensive. So I'm doing this on a 8-core Mac Pro, but were I to do this on, say, a Windows laptop with the good old Realtek drivers, my CPU wouldn't be at a nice 0 to 1%. It would probably be closer to 5 or 6% just for these 4 snapshots, plus this 5th one right here that's doing the integers. It's not really good in terms of CPU efficiency, but with modern CPUs, it doesn't matter as much. But that's just a combination of the line, the curve, and the no transition, just to demonstrate what those sound like and how you can incorporate those into your patch to get some smoother automation of different parameters.